we're looking at the derivative function today. We're looking at it in terms of exponentials. We've talked already about having a derivative of e. If we do the derivative of e to the x, it is simply just e to the x. It is the easiest derivative, and then obviously the easiest integral in the world, just e to the x. Now, it's not always going to be e to the power of x. We might have a different number instead of e. Well, the only difference is, all we're going to do, we're still going to have it rewritten, but we need to have a little constant still put in there, the natural log of 2, just another number. So same thing down here. 5 to the x becomes, when I take a derivative, 5 to the x times the natural log of 5. And actually, that's not anything new, because when we did this before, we actually should have said, yes, times the natural log of e. But what is the natural log of e? Natural log of e is just log base e of e. That means that that is actually equal to just 1. So e to the x times 1 ended up being my answer. So same thing over here. When I do this integral, I'll still have 2 to the x, but instead of now multiplying by this natural log of 2, I'll divide by natural log of 2. And same thing here. I'll have 5 to the x, but now I'll divide also by the natural log of x. And of course, my plus c's at the end. So now, to look at some more complicated problems, of course, because we can't just make it that easy. Let's start with this first derivative. I have x times 9 to the x. Well, I have a product, so I'll do product rule. First times the derivative of the second. So 9 to the x is my derivative, but I also need to multiply by ln of 9. So x times 9 to the x ln of 9 plus the second, which is 9 to the x, times derivative of the first, which is just 1. Now, usually in a multiple choice answer, they'd probably try to factor something out. They'd factor out that 9 to the x. So I would have x times ln of 9, or really you might have that backwards, ln of 9 times x, and then plus 1 for my second term. Alright, this next one here, I have 5 to the negative 4x. This is a chain rule problem here. So I'm going to rewrite it 5 to the negative 4x times the natural log of the base, natural log of 5. But I also need to multiply this by derivative of the inside, derivative of my exponent, which is negative 4. So I would probably have this rewritten as negative 4 ln of 5 times 5 to the negative 4x. So something maybe looking like that. Alright, now we have integrals. In this first one here, I have a sum as my integral. That means I can do each one of these individually. Integral of x squared dx and the integral of 2 to the negative x dx. This first one I know I can do. That's going to end up being 1/3 x cubed. For that one, we've done that many times before. Now, for this one right here, we're going to have to do a u and du substitution. So this is going to be u is equal to negative x, and du would be negative dx. So I will rewrite all this as, I'm going to keep the first one in there anyway, x squared dx, plus this will be now the integral of 2 to the u, du. It was du over negative 1. So instead of a plus here, this will end up being a minus as a result. Now let's evaluate these integrals. I'll put that here in pink. I'm going to evaluate the integrals. Now it's 1/3 x cubed. We have minus 2 to the u, which is now over ln of the base, 2, plus c. And then I finish it off by putting it back all in terms of x. 1/3 x cubed minus. This is 2 to the negative x over ln of 2 plus c as my answer. Alright, and this last one, I have one more that I'm going to do, a u and du. If I make my top as my u, do I have anything canceling out down here? No, it doesn't look like it. So the other question, do I make just the exponent or the whole term? If I do just the exponent, du would be just 2, and that's not going to cancel out. So my bottom is my only option, 1 plus 3 to the 2x. The derivative of that would be 3 to the 2x times what else? Times the ln of 3 for the base, but also what's the derivative of the inside? The derivative of that inside is 2. So there's a big long term of what's happening there. So let's see now if we can actually evaluate this. So we'll have the integral of that 3 to 2x was still there. The bottom is now u. My dx now, this should have been dx. My dx is now going to be du over a lot of things. 3 to 2x, also an ln of 3, and also a 2. So let's see what we have that cancel each other out. The 3 and 2x's cancel out, and I have these other constants that are going to go outside. So I'm going to have 1 over 2 times ln of 3 on the outside. My inside is now 1 over u du. So that means now when I evaluate this integral, I'm keeping my constants. 1 over u, its integral, is actually the natural log of u, absolute value of u, plus c. Let's plug back in. So we have 1 over 2 ln of 3 times the natural log of u, which is 1 plus 3 to 2x plus c. And if you got to that step right there, I would be pleased with that. There's a lot more simplifying you can do. These absolute values don't need to happen because this will always be positive, so you can get rid of them. And there's rules with natural log of quotient could actually mean you could subtract things in the middle. I'm not worried about that. If you can get to this step right here, I'm happy. So there's how you do derivatives and integrals of x